Okay, if we could try and make a start. Okay, so welcome to the second session of the SIXNet workshop. We'll start with the presentation that we held over from the earlier session. This is a presentation on mobile IPv6 within SIXNet. It will be provided by Chris Edwards, who is a researcher at the University of Lancaster in the UK. Over to you, Chris.
Okay, thanks very much. Can everybody hear me? Yeah? Okay. I'm actually a lecturer at Lancaster, just to correct Kevin. But so one thing that I have realised being involved in the SIXNet project is that everybody likes to talk. So hence the reason that my presentation is about half an hour late. So I'll be quite quick, but being a lecturer, I normally like to talk for about 50 minutes as well. So, but I'll do my best to keep it short. What I'm going to do today is try and give you a little bit of an update as to where we're up to with mobile IPv6 within SIXNet. So I'm going to talk a little bit about what the protocol is all about, just to, for those people who perhaps have no experience of what mobile IPv6 is all about, I'll just give a very brief overview. It's quite difficult to overview quickly, but we'll have a go. Tell you a little bit about the status of the protocol, both in terms of its internet draft and RFC status and the available implementations, what you can download now to use within your sites. And then we'll talk a little bit about the trials that have gone on within the context of the SIXNet project. Okay, so do people roughly know about mobile IPv6? Is there anybody here who doesn't know at all about mobile IPv6? Okay, so I guess I can be really quick with running through the overview slides that I had. Effectively, mobile IPv6 is a bit of a strange routing protocol, if you like. It's a routing protocol purely for mobile devices. So we have the situation where a mobile device wishes to roam to a different network, and we want to get traffic that's aimed at that device actually directed to where the device has moved to. It's a strange protocol in that, a strange routing protocol, in that we actually really try to completely avoid doing anything with the routers in the network. So we really don't want the routers to know anything about the mobile devices and the movements of those devices. And the way we do that is to basically define a number of places that we are going to hold the state to do with the moving of the mobile nodes. And those places are the mobile device itself, what's called the correspondent node. So that's effectively the node that the mobile is communicating with. And we have an exception to the rule in terms of having the routers involved, in that we have this device called the home agent. So the home agent basically belongs to the network that the mobile device was originally related to, and acts as an agent for that mobile device as it moves across the internet. So our mobile nodes acquire a home address and a home agent. That's what they do at startup effectively. When they move away from home, they then basically get what's known as a care of address. We register this care of address initially with the home agent, so that any traffic that's aimed towards the mobile node is redirected by the home agent itself. Eventually, we will also register this address mapping with the correspondent node itself, so that we can avoid any triangular routing between the correspondent node, the home agent, and the mobile node. So we do away with the triangular routing altogether. And so mobile IPv6 ensures that we can route the packets in the right direction. So the key to the protocol really is this mapping between the home address and the care of address. And that's held in what's known as the binding cache. So the binding cache will exist both at the home agent and at the correspondent node. And that's, as I said, the mapping between the home address and the care of address. What this allows us to do is basically have seamless routing to the device as it roams around the network. I suppose the final thing I should point out about the protocol is that there is something called a binding update, which issues the messages both to the home agent and the correspondent node. And it's basically the binding update message that does the registering of the address mapping within the cache. So for those of you that do know a little bit about mobile IPv6, one of the real problems that we've had with the protocol over the past, I don't know, it must be 3 or 4 years, is this ongoing process within standardization within the IETF. So it's gone up to draft 24 within the IETF. So that's quite a lot of iterations of the protocol. And that's really, a lot of that has been down to the problem of authentication. And basically somebody pointed out, well, surely what we could do if we were an attacker and we wanted to bring this, we wanted to cause trouble within this network, is we could actually start sending bogus binding update messages. So we could send these binding update messages to the home agents or to the correspondent nodes, and to pretend effectively that we are a mobile device that's moved from one point in the network to the other. So there was a lot of work done, and I'm not going to go through it within this presentation because we would be here all day, but if you want me to try and explain the rules of return routability, I'm quite happy to do that later on, and we'll get a piece of paper and I'll kind of draw it out for you. But what we needed to do within the IETF was work out a solid means for making sure that when these binding update messages are sent from a mobile device, that we could actually verify that these messages were from who they claimed they were from. Okay, so in terms of the protocol itself, we finally got to the point where we have reached a standard within the IETF. So mobile IPv6 has been accepted by the IESG, so it's moving to RFC. We're just purely waiting now for the RFC number to be issued for the protocol. We have a number, right, since... Right, super. So, I don't know, do you know what the number is?
Yeah, 3775.
No. So, you heard it here first. We have a number. My slides are wrong. But I did write these slides 2 weeks ago, so they're probably right then. We have now seen the mobile IP working group come to an end, which is basically, I guess, the guys who have been through this sort of hellish standardization process have probably said, enough's enough, let's launch some new working groups that are looking at some of the newer issues now that we've actually nailed down the protocol. So we have the Mix 6 working group that are looking at some of the deployment issues, if you like, with mobile IPv6. And this kind of overlaps with quite a lot of what we're doing within 6net. So looking at some of the longer term issues, if you like, so such as perhaps if we wish to have multiple home agents available for reliability, that sort of thing. And we also have the MIP shop working group, which is looking at the handoff optimization of mobile IPv6. Hello? It's good to talk. Okay, so we have those few working groups that are beginning to get their work underway. We also have now some significant implementations available for mobile IPv6, so that are now effectively RFC compliant. We have the Linux MIPL implementation, which is currently available for 2.4x kernels, but will be updated to be available for the 2.6 kernel very soon. BSD implementations. We also have a Cisco home agent implementation, which is available as an EFT release. So if you have access to the EFT software at Cisco, then you can download this and run this. And there is also a Microsoft alpha release of this that we're actually playing with at Lancaster, but we can expect a beta release of this quite soon, I guess. Deployment within 6net. Several mobile IPv6 testbeds within the project. I think we've got 7 partners that have each got their own mobile IPv6 testbed, with different focuses at each of the testbeds. So some of us are looking particularly at the conformance to the specification. Some of us are looking at the interoperability between different implementations. Some of us are looking at it specifically from the application perspective, so how mobile IPv6 deals with multimedia streaming handoffs and that sort of thing. We also have a partner that is looking specifically at multicast in the context of mobile IPv6, and they've done some nice but fairly theoretical work. And what we're trying to do is we're trying to kind of cover a multitude of sins within 6net, so that by the end of the project that we basically have a very concrete and very solid view about the issues that there are with mobile IPv6, so that we can advise people within the community about what the positives are, but also what the negatives are of bringing and installing mobile IPv6 into your organization or your university campus. So they're the testers that we have with the different implementations that are available to us. I'm just going to skip through some of these because we have a few more to cover. So this is the kind of how it fits into the 6net topology, if you like. Different implementations being used at different partner sites. What this type of thing enables us to do, certainly in terms of looking at the handover consequences, is that it allows people at, for example, Lancaster, to register their home agent as perhaps being somebody at Focus in Germany. And so that enables us to do some nice handover measurements to see just how long these handovers take. So we've waited a long time for the standard. When this project started, the standard was just around the corner. And 3 years later, we've just about got it. So we're looking at conformance, we're looking at interoperability, handoff performances, but we're aiming a lot of it towards this final guide that we will release in December, which is basically a cookbook. It's a how-to, again within the context of 6net, that is going to explain to people just what the issues are with deploying mobile IPv6. There is a lot of other work within the community going on outside, but closely related to the work in 6net in mobile IPv6. So we have the Tahi test suite that's being used at Connectathon. We also have the IETF remote interop testing, which is effectively a body which is available to allow us, or allow anybody in fact, to register their mobile devices with these guys. And so to enable you effectively to have mobile devices that without you going about setting up and configuring your own home agent from the word go. So there's some pointers within the draft to that. One of the things that we're also very, very keen to do within 6net is to drive everything that we're doing within mobile IPv6 right towards the application. So actually, now and towards the end of the project, we're focusing really on saying, right, the protocol is here, we understand it, we understand how it works, we understand what the problems are, but let's build this in to some application scenarios. So this is one of the first applications that we've developed and was demonstrated to the Commission last week, which is basically looking at this idea of having a couple of mobile nodes and a correspondent node, so a node that these guys are communicating with. One of them has a camera, and the other two nodes basically want to play out what the camera is streaming. And they're registered to their own home agent, and we're able to see the way that these mobile nodes roam between networks, what it actually looks like to see a handover take place between the networks, and in fact the impact that you see, or in fact the lack of impact that you would see on the stream as you move from one network to the other. So we're looking at this idea of seamless handovers. There is work going on within the project and also within the IETF that is looking at this idea of fast handovers. Fast handovers is effectively the concept where you basically say that you can in fact predict that a mobile node is going to move somewhere. And if you can predict that it's going to move, and in fact you can predict the IP address that it's going to get when it does the move, then you can do some of this message passing and some of the binding update sending before the device actually moves. And so we're going to be looking at and trying to measure whether this idea actually helps or whether it hinders. The problem you have with this fast handover idea is if it looks like a device is going to move, so you start the message passing, but then in fact it doesn't move, then it can cause a number of problems. So we're going to be looking into that as well. And finally, we're looking at this idea of network mobility in the context of mobile IPv6. I won't talk about this too much because this is the stuff that Jane introduced in her first presentation this morning. But effectively what we're talking about there is saying that instead of having a single PDA or a single laptop that is your mobile device, you have a router that is your mobile device. Okay? So the router that is moving effectively has a home agent related to it, and off that mobile device you could in fact have a number of other mobile nodes. So if mobile IPv6 wasn't complicated enough, this gets really quite complicated because you're talking about a hierarchy of mobile networks. And again, you know, what are the route optimization issues? What are the handoff issues in this context? And we've got some interesting deployment scenarios. So we're looking at this idea of remote network support that Jane introduced earlier on today, where we have schools connected in the region where we are in Lancaster. And quite often this network connectivity goes down, so we have to scramble a network response team. And we're actually talking about deploying mobile IPv6 and one of these mobile routers into this network response vehicle to enable the guys who are going out into the field to remain connected via whatever means is available to them. And we've got a number of other scenarios that Jane talked through. Okay, so I think I'll leave it there. Sorry it was a bit rushed, but if I've just about got my head around the return routability idea, so if anybody does want to challenge me to try and explain it later on, I'd be glad to, I think. Or maybe over a beer tonight. Okay, thanks very much.
Thank you. Okay, well, I suggest that we're running very short of time, so if you have any questions for Chris, then please approach him after this session during lunch or later in the day. Okay, the next presentation is given by Patrick Grostet, who is the Cisco IPv6 project manager. As I said, Patrick is the IPv6 manager for Cisco, and he's also been heavily involved within the 6net project. So with that, I'll hand over to Patrick, who will talk some on the prospects for IPv6 in the near to long-term future.
Thank you, Kevin. So, good morning. I think I'm very lucky I can say anything. You won't be able to check right now if it's true or not. But at least that's the view I have on what could be the good prospect for IPv6, just to make sure that we are successful with the technology. So I split the presentation in two parts. The first one is what I call the building the IPv6 house. I mean, where are we in the short term, and what can we do just to improve the deployment? And the second one is what are the prospects? What are the areas where I think there is a great opportunity for V6 and for research as well? So the first thing is I need to go back and just do the 101 on V6. That's what I call the basic perspective. If I look at the end user today, nobody cares about V6. I mean, what the end user cares, it's really about application and services. Let's say, for example, I had a discussion with the Linksys people, the guy who are selling the small box. Let's say we can put an IPv6 inside logo on the box. Do you expect to sell more box for that? No, nobody really cares. It's really focusing on application. Now, if I look at network manager and service provider, what they care about V6. but a lot of them are still afraid of it. They don't know how to manage it. They know that it will cost money to train people, and they have to deploy it and manage it. So here, what we have to make sure that we can get people confident with the technology itself. Now, the other thing is, too many people expect that, okay, IPv6 is there and you should be getting everything in one day. And I'm sorry, but the best comparison or the best analogy I can do for V6 is regarding how you can build a house. The first thing you have to do is you have to talk with your wife, and you have to decide that, okay, we have the money and we should be build. I mean, for any reason, maybe the family will grow or something. We need to work on something. And that's exactly what was done at the beginning of the 90s when the IESG decided to go for a new version of the protocol for IP. And that was like for doing the foundation. And from there, you got a lot of people working on specification, coming out with all the RFC, people like Steve Deering and Bob Eden. This is the core spec, and the core spec has been available since between 95 and 98. And from there, you need commercial implementation. What we have done, if I look at the past, what we have done at Cisco, we delivered the first EFT implementation in 1996. But in 2001, the feedback we were getting from customers in some region was, don't expect us to go to production without full support. And full support doesn't mean, oh, by the way, here's the software with the features. Full support means the support center must be trained. We must accept call 24 hours a day and 7 days a week and a year. So that means we must have documentation, we must have training. So that's the main reason we put V6 as part of commercial release in 2001. And if I look at the market between 2001 and 2003, all vendors have added IPv6 as part of their product. And at the same time, it's very useful for a vendor like Cisco to learn about how people are using the technology. And I think this is where 6net provided us a great value by deploying V6, native V6 on a large scale, and doing a lot of experiments to say, okay, this part is working well, this is what is missing. And you have seen from the previous feedback that we still have some missing activity. And we have seen V6 going to production for the NRN community through GEON and all the national and research networks. At the same time, some people have been stating that, oh, IPv6 is not stable enough. And the reason is IETF is still working on a new protocol and new specification. But I would say that's something very, very normal at the IETF. A protocol is live when people is working on it. The day nobody will be working anymore on V6, it means V6 will be a dead protocol. So what we have seen very recently, we have seen protocol like mobile IPv6, DHCP-V6, prefix delegation, flow label. That's the new RFC coming from the IETF. But my point on that is, it's like building the house. The first thing you need commercial support, you need the operating system support, and from there you can work on the application. And this is where we are today. That means we can look at V6 and say, okay, now how could we move V6 to full production? At the same time, V6 itself is not really important. You cannot say, I'm doing V6 without considering the other technology and the other networking trends. So here on the slide, it's something very important. The first thing is simplicity of Ethernet. I mean, what kind of technology everybody is deploying today? At home, for your campus, it's Ethernet, from 10 meg to 10 gig. So here, the good thing is V6 is running on Ethernet without any problem today. At the same time, we need the content. I'm just back from the motorcycle Italian Grand Prix, so it's direct photography. And this is where, if you look at what's shortly happening with broadband services, everybody's talking about triple play. And triple play means I will be able to do TV distribution over DSL. And by the way, here, if we look at multicast this can be a great opportunity for triple play. We need to increase capacity as well. I mean, well, that's the CRS one. I'm pretty sure you have read about the announcement. But if I look at the what people are doing for triple play, when you start distributing TV channel with high quality, that means at the aggregation layer, this is where you will need the optical capacity. And then we are moving the internet from fixed internet to wireless internet. So this is where we have to make sure that we can add mobility to the to IPv6 as well. And here you can see a 3G phone. At the same time, we have to make sure that the internet stays a single internet. That means it must be available in any region of the world. And we must avoid balkanization. So that's what I call ubiquity of the internet. At the same time, we know that security and privacy is something very important. So we are working with V6, but we have to consider how V6 can support all the trends currently ongoing for networking. So the first thing is, I really consider that V6 will only succeed if we can add V6 to broadband access. I mean, if we look at V6 today, look at your campus network, look at DIE, why do you need V6? I mean, if I have a single PC at home, and if the only application I'm doing is reading my email and browsing the web, I can stay with V4 and that. So the only reason V6 will succeed, and what is the purpose of V6? V6 is to grow the internet, to scale the internet, put more users, and put more devices. So this is exactly what broadband is offering. So that means here, I can expect to see many new applications and many new devices. And this is how a service provider can generate revenue from the connectivity. So I would say we cannot split IPv6 from broadband. That's something very important. The second area, the second technology domain for V6 is mobile wireless. Here, and that's something very important. I'm pretty sure you remember all the announcements regarding 3G in Europe. The fact is, wireless does not mean 3G. We have to split wireless between what I call unlicensed band, like Wi-Fi, WiMAX, and this is where you can do V6 today. I mean, if you look at all the hotspots that are opened by service provider, it's very easy to add V6. I mean, just put V6 on your router, and from there you can start providing the connectivity. And by the way, remember that any PDA running mobile PC 2003 is IPv6 capable. At the same time, we have what we call licensed band, like GPRS and 3G and 4G later. This is where V6 will be coming later. And the main reason is the model is more complex. And you also need a client. I mean, don't expect to get V6 being successful here if you don't get a client like mobile phone supporting 3G and V6 as well. So we have to make sure that we can split between unlicensed and licensed. At the same time, we have to look at the number. How do you want to integrate IP on mobile wireless without V6? Today you have 1.5 billion GSM users. That means the only way you can put V6 on top of that, on top of this network, or IP, I mean, is by doing V6. At the same time, you also have the always-on connectivity for this cable. So the first proposal here where we are, a lot of people have been talking about migration or transition. At Cisco, we have always been talking about integration and coexistence. But more recently, but looking at the industry trend, I'm calling for IPv6 integration per application. And the main reason is, if you look at all the operating systems today, they are dual stack. So that means there is no reason for end user to change what is working well. Like, I'm reading my email, I'm browsing the web. If I can't do it over V4, it's not my first priority to go for V6. On the other end, if there is services I cannot get from V4, like for example, I'm behind an ad box, and you will see some example later, this is where I have a strong interest to integrate V6 and go to V6. So the first thing is, don't break what is working today. Look at adding new services. That's really what the end user is looking for. So that means here, by the way, remember, you are getting V6 from all the platforms today, operating system. You have application. You can go to the 6net page. But remember, V6 is not only for computer. And this is where the Japanese industry is leading the world today. All the electronic vendors in Japan are looking at embedding V6 as part of the product. And this is where we need to do something for the European industry as well. People like KISS Technology and Philips or Ariston, all these people who are working on electronic consumer devices. We have to make sure that the European research can help them and to go to V6. We are also facing some non-technical challenge. And that's very important to understand the challenge, because very often if you read the press, people are doing a match, I would say, are linking the challenge to IPv6. And it's not true. Like the first one is IPR. IPR has nothing to do with V6. I mean, people who are downloading MP3 and video today, they can do it for V4 using CASA. So the reason is it's not because you are deploying V6 that you will get more, or maybe you will be getting more people doing that. But it's really education, and it has nothing to do with V6. At the same time, something really important for V6 is education. Remember, every people who are going to university today may be the next network manager for an ISP, for an enterprise customer. So here we have to make sure that V6 is part of the next I would say, of the training for next generation graduate. And this is, I think, where Europe may be leading. Through projects from the European Commission, like 6net, we have a great opportunity to take what 6net did and put that as part of the curriculum for universities. So now we can bring people in Europe and make sure we will train them. At the same time, we don't know what will be the social impact from V6. I mean, not from V6, but from the broadband model. How people will use new equipment. What will be the privacy rule? So that's one of the areas where we have to work, and I know George has been working on that, publishing some paper. And remember that the internet is decentralized. So don't expect V6 to be deployed at the same rate in all regions or in all market segments. So once again, if you are working with different partners and you are focusing on different market segments, the interest for V6 can be different from one region to another one. So let's look at the prospect. The first one is, and that's something very important for enterprise and for service provider. We need to look at the business model. And here I'm mostly focusing on the service provider. The first thing is, if you look at how service providers are making money today, they are making money by charging for IPv4 address. If you go for broadband, for DSL, what you are getting by default is dynamic IPv4 address. If you ask for a static address, most of the time the service provider is charging you for that. So here, by looking at V6, and that's another area, very often we have been comparing V6 and V4 in regard of address space. But we are not comparing the same data. If I'm looking at broadband access, what you are getting for V4 is a single IPv4 address, either dynamic or static. When I'm looking at V6 over broadband access, I'm looking for a prefix. Minimum will be a /64 or /48 or something between. So that means here we have to work with service provider to make sure that they understand new model and they can adapt their business model to that. The third one is provisioning for always-on technology is really different of what they are doing for DSL. I mean, if you look at the way they are managing DHCP allocation today for V4 over broadband, most of the time you have a ratio of one address for 2 users for good service provider, and some of them worldwide have a provisioning ratio of 1 to 15 users. There is no way you can do that with V6. I mean, if you expect end user to deploy many devices, they will expect a stable address. At the same time, we need to work with the ISP just to make sure that they can get added value as well and services. And the added value and services are coming from the endpoint on how you will serve the endpoint. I would say the best example I have seen so far coming from a service provider is the one from NTT.com. with what they call M2MX, where you can, I would say, secure the access of devices. And I just put the URL for reference. At the same time, we have to look at traffic evolution as well. What do we try to achieve with V6? With V6, we try to come back to the original model of the internet. That means, original model means you may have client-server application as today, you may have peer-to-peer, like Grid, or you may have server-to-client. Server-to-client means the server will be on the edge of the network. And you can do it today with V4 if you have official address space. What we try to do with V6 is provide the address space so anybody can run any kind of application. But what is the impact on the traffic? The first thing is the traffic can be symmetrical. That means if I look at what people are deploying today, DSR is not symmetrical. So the evolution for broadband access should be Ethernet to 0. And once again, if I look at what's happening in Japan today, that's the trend over there. Very long session. I mean, when you have always on device, you may just connect your device for 24 hours a day. I mean, I have children, and I know they are playing with SCADA. And the computer is, I would say, just on for days and days. So here, it's just changing the traffic pattern on the network. At the same time, you may need high bandwidth. And once again, high bandwidth in Europe or the US is different from high bandwidth in Asia. So here, that means if you have many devices, and any computer today can take the overall bandwidth from a 10 meg or 100 meg. So that means we need high bandwidth capacity. And remember, if we are looking at video streaming, we need to do the aggregation for that. And the other revolution is traffic is non-local anymore. I mean, if we go for symmetrical traffic, if we go for peer-to-peer application or server-to-client application, that means a service provider cannot expect the traffic to be local. That means here, that will put some pressure on the internet exchange point as well. Technical challenge from IPv6. This one are still research area. The first one is multi-homing. Remember, you can do multi-homing on V6 the same way you do it for V4. So once again, we must make sure that people understand why there is no multi-homing to do on V6. And the reason is the regional registry just want to avoid the issue we are facing with V4. I mean, the growth of the routing table. So just from the charter of the multi-6 working group, we want to define new multi-homing capability where at the same time we can keep the aggregation of the routing table for V6. So that is the first challenge. The third one is security. I know IPsec is mandatory on IPv6, but security is far more than IPsec. I mean, and if I look at enterprise customers, they want to centrally manage the network. That means using firewall. That's what they are doing today. So now if you try to do IPsec end-to-end, what should be the relation between the firewall and the host? So here, nobody had the answer. At the same time, remember, key management has nothing to do with IPv4 or IPv6. And we still need to find a solution for the internet. And the last one is dual stack network management. V4 and V6 will be there for years. So you have to make sure that we can get instrumentation, like the MID, like NetFlow. You need the application. But when I say application, it's not only SNMP. It's also billing application, provisioning application, traceability. So here, there is a lot of activity where we still need to do research. As I said, that could be part of the system activity as well. Now, the good point with V6 is V6 just enable opportunity for new ecosystem. New ecosystem means here, if I'm looking at the broadband access model with the host, that's just a short, or I would say, an overview of all the devices you may have at home. So what could be the business model for that? My preferred case study is the fridge. And the reason is, I'm using the fridge because very often press release and news are using the fridge. Oh, by the way, this is the fridge with IPv6 connectivity. So, and the next question is, okay, what can an end user do with a fridge? So the first thing here, I really consider the fridge as something you may connect to the internet. Now, don't expect to use the fridge to read your newspaper or to browse the web or to send email. Now, let's see the business model. Today, when you buy a fridge in any European country, if the sales guy is a good one, the proposal will be for, let's say, 100 euro, you will get 3-year warranty extension. It's mostly true for all the countries. So now let's say, for 100 euro, you have a broadband connection, and by the way, the retailer can sell you the broadband connection, you will get 3 years telemaintenance. What is the difference for the retailer? Now, the retailer can keep in touch with yourself as a customer. And that's something very important. And I can do telemaintenance. At the same time, the guy can say, oh, by the way, I can just pre-configure your fridge. So now from the graphical screen here, you can access the online ordering portal from vendor X. That's something very important. Why? I can do online ordering today using my PC. But the first thing is, PCs are not for mass market. I mean, I know what, my mother is calling me very often just because she has trouble with a PC. So don't consider a PC as mass market device. This is a mass market device. So here you may have a very simple graphical interface. The second one is, when I'm doing online ordering from my PC, I can go to vendor X one day and vendor YZ the other day. Here, by just presetting the configuration to a portal, I can make sure that the customer will stay with me as a retailer for the next year or 2 years or 3 years. So it's a win-win situation. We can expand the market, and just by providing and supporting 2 applications on the fridge, we have a valid business case. I'm not talking about reading my email. I'm not talking about doing file transfer. I'm just talking about telemaintenance and online ordering for mass market. That means from there, we can expand the marketplace for IPv6 and for our IP in general. That means here I can go for digital theater, photo services, digital studio. So here, if we are just limiting the number of applications per device, now we can expand all the places where IP has a value. Another area is what we call network in motion at Cisco. That means looking at transportation. And that's what we try to do with the mobile access router. So here, if I take, just as an example, I will take the Renault car. So here we put a mobile router as part of the car. Now, that means you can connect all devices, not only the devices for yourself. I mean, you can still browse the internet from the car, but who is browsing the internet when driving the car on the highway? I mean, nobody. At the same time, I can do telediagnosis of the car if you are in trouble. I can do localization. I can send you information, like, for example, if I look at the car navigation system today, you buy your DVD once a year, but a month later, it's just obsolete. Now here, with an hard disk drive, you can go in a toll station or gas station and just download the latest information for your car navigation system. At the same time, the gas station can sell services, like you want to download your MP3 or your MP4 movie just for your travel on the highway, you can do that. So here you have business model associated to that as well. More important, this one, that's my preferred slide. Because I'm 100% convinced that the best feature we could introduce on V6 will be easy closed user group. That means, remember X25? That's exactly what we are looking here. Let's say you have multiple devices. Remember my slide on broadband access with all the devices at home? IPv6 means global reachability using global address. But it doesn't mean you want all your devices to be available from the internet. I mean, there is no reason somebody from one region around the world try to hack my fridge. So here, what I'm looking at creating user group. The best example or the best analogy I can take is look at what you are doing with Instant Messenger. You can define group for your friend, your family, and you can share pictures. That's exactly what will make sense here. I may have a network storage at home. I may have a video camera at home. I want to define a group where people will be able to share these devices. But I don't want this device to be reachable from the overall internet. At the same time, if I'm a utility vendor, I'm utility like power utility, I may put the meters, and I may want to use your broadband connection just to access the meter. But it doesn't mean the power utility want to share the information with the water utility or with anybody on the internet. So once again here, what I'm looking at a single network connection I can share with multiple devices. At the same time, I can create closed user group for this device. And I don't have the solution yet. But I can tell you that that will be the greatest feature for IPv6. So let's take a case study just to conclude the presentation. My favorite one, because we are currently working with some country in Europe who wants to do that, it's how we can deploy V6 in the school. And once again, I'm just focusing on the business level. What is the school business? It's education. And education like reading, write, mathematics, foreign languages. And if you look at that as a foundation, that's also the foundation for internet. I mean, you cannot access the internet if you don't know how to read your web page. Or if you don't write, you will never be able to send email. So here, that's the minimum requirement. That means it's very easy to work with the teacher to say, okay, internet is part of the life today. That's the benefit. At the same time, remember that analytic mind is something very important if you want to make sure you understand all the fraud and all the wrong messages on the internet. So I think that this is where education is very important for the next generation of children. At the same time, schools are part of the information society. I mean, they are getting access to the internet today, most of the time through broadband access or lease line, and they are linked to NRN or local government. Application and services, what kind of application and services are they using today? Most of the time, client server, email, web browser, and web server are generally hosted externally. And most of them are using PAT, not NAT, PAT, a single IPv4 address for the overall school. Now, let's look at new class of application for the school. Class-to-class collaboration, locally, national, international, that's something very important. Sharing database, creating server, teacher-to-student collaboration, how we can help your student, after-time support, dormitory for universities, content delivery between school and information provider. Most of the time, every country has a very large database, historical database for movies. IP telephony between school, telesurveillance. I know physical security is something very important in most of the European countries as well. Secure information. How do you want to share information between administration for the school? So this is all kind of application where we can take benefit of the IPv6 capability. So here, what we are looking at is how we can just add v6 configuration on the access CPE device. I'm not looking at touching what works very well. I'm just saying, okay, as your router, your access router, and by the way, if Cisco is good for everybody, you can just configure v6. And from there, just configure v6 on your box, You can get your prefix from your national research network or local government. And from there, you can just keep your application as they are running today, but add all new services here running V6, like doing multicast streaming, for example. And I just put a small slide, very short configuration. So just to conclude the presentation, I think V6 is a key driver for the e-economy. Don't expect V6 to be the same in all world regions. Like, for example, you will see that in Japan, V6 is really tied to broadband access and to the electronic consumer market. In some region, the main driver for V6 is the lack of IP address for everybody. And for other parts, it will be market segment. So the perception in regard of V6 is very different in regard of market and region. But that's a key driver for the today world. And that's it.
Okay, as I believe Jordi has to switch over onto his laptop, I guess we have some short time for questions, if there are any. Okay, well, the next presentation is once again by Jordi Palette, who we introduced earlier. This presentation is on an interesting project in the IST program called 6Power, which is implementing or rolling out IPv6 over power lines. So hopefully this time it doesn't take more than a few seconds. Okay, well, yeah. We know it's coming.
No, this time it seems faster. Well, it seems. Okay, anyway, let's start. The first thing I am going to introduce is how power line technology works, because probably most of you are not aware of it. So this is the typical diagram of a power line network. Actually, it's only the last half mile, because what we have usually here is the medium voltage network, and this is the low voltage network. We can use today power line already in the medium voltage network up to a distance of 3, even up to 5 kilometers. In the medium voltage network, the distance is half a mile, but usually this is the distance that it's already the usual distance for the electricity to be able to work. So it's not a problem for data communication, it's a problem for electricity itself. So what we do is we get the signal injected in the medium to low voltage transformer. This signal can come from the medium voltage network or can come from other media, like for example fiber. There are a lot of electricity suppliers that have fiber inside the electricity cables, not in the last mile, but in the medium voltage and the high voltage networks. So what we have is this device here that basically is a PC with Linux, which maybe gigabit card, and then a PLC interface card. And this PC, this Linux industrial PC, is the one injecting the data into the last half mile. And then we have, in different situations, different type of buildings, individual homes or offices or flats, building of flats, devices like, for example, set-top boxes, and the set-top box can have connectivity to power line, satellite, ADSL, different technologies. And of course, we can use the power line not just to provide access to the home or to the business, but also to provide connectivity among the devices inside the home. So we are able to have internet connection and consequently data connection to any plug that we have in our home. And of course, this could be also combined with other technologies like, for example, wireless LAN. So it provides a very good mean to really cover all the home without the need of wiring the home or putting just a single wire for the access point for the wireless network to be in the center of the home, because we know that the distance is short. So usually we put the wireless access point in the place where we have the connectivity from the ADSL provider will not reach the rest of the home. So that's a very simple way to do that. So obviously the advantage for Powerline is that we have the grid already deployed everywhere. So just we can imagine converting today traffic lights or information panels in the streets, or even advertisements that have already electricity because they need a light to illuminate the advertisements during the night, into live information panels. Or for example, use the electricity grid to install wireless access points or 3G base stations wherever they are needed. Actually, I know 2 weeks ago already that the Spanish deployment of 3G is already using Powerline now, because they don't have enough infrastructure to deploy, and it's very expensive to deploy the electricity network whenever they need to put a base station, and in addition the data network to the same place. So they just use the same cable, the electricity cable, to deploy the 3G base station. So simple and so cheap. Of course, we have, for example, vending machines. We don't need to make a visit every day to the vending machine to know if it's empty of coins or if empty of any product. We just get through the Powerline itself, because the vending machine, it's usually all the time connected to Powerline, whatever information the vending machine needs to provide to us. So we can do any remote maintenance of the vending machine. About the speed, today with Powerline, commercial product already since 2 months ago, we have 200 megabits. Before it was 45 megabits. And we have now deployment of real Powerline in Spain since September last year, in the rest of Europe, in Latin America, in Asia Pacific. Several places in the world are already using Powerline. In fact, thanks to the results of this project, 6Power, the electricity suppliers in Spain took the decision to go to Powerline in commercial, because before the project started the work, they were able to provide very good data connection, internet connection, but when they tried voice over IP, the quality was not good enough, which part of the development done by the project improved the quality of service features in the chipsets that provide the connectivity. They were able to decide, okay, now we can go to Powerline plus data voice service on one shot. And I already mentioned, combining Powerline with wireless line probably provides a very good way to offer new services. One important thing is, as in any technology applications, today we need, or we are using more and more bandwidth every time, and applications are also more and more always on connected. We have seen a lot of examples in the previous presentation. So if we really want to have all the applications always on and all the devices, and all these devices need power, for example, the concept that we have in Europe, ambient intelligence, it means we have a lot of sensors around us. It seems fiction, but it's already coming. All these sensors need electricity, and all these sensors need to be connected, and all these sensors need to be addressed. So we are combining here connectivity with IPv6 because the addressing, and we are combining, of course, always on, not just in the sense of the data, but also because they need electricity. So why to deploy these devices or these networks of devices, put to every device 2 cables, one for the power and one for the data? Really, it's not interesting, obviously. I have always this example about the intercom. This is the device that we have in all the buildings where you can ring to get somebody in the flat to open you the door. Okay, what happens if I forget the keys and my wife is not at home? The intercom is an electricity device, so it's very easy to connect this device to internet and make able that when I am calling, if nobody is at my home, my wife at the work or shopping with a PDA, with a cellular phone, with whatever, can got the call redirected, see I am there waiting, and open me the door. Or maybe myself, I can got the call redirected to my cellular phone, and opened myself the door. So simple. It seems a stupid idea, but it's just electricity. So it's something that it's very easy to do. So what we have done in this project, we have combined several technologies. One of the technologies that we combined with IPv6 is universal plug and play. Universal plug and play is a technology that enables a very easy discovery of the control of the devices and the services that are available in the network. So we have 5 minutes. Okay. So what we are using is using universal plug and play that already supports IPv6 together with other technologies for offering home automation and surveillance, all kinds of services. In fact, the slide from Patrick before, remember very, very well our scenario. Another advantage is universal plug and play offers zero configuration. Which universal plug and play, what we have is the devices that describe themselves what functionalities they have, and they announce via multicast all these services so the control point can discover all the services. Of course, they have also XML files that could be interpreted by the control points, and also they can have HTTP pages so the user can also directly talk to the devices if necessary, but usually it should not be that way. The application we have developed, 6plug, what it's offering is a secure access to the home or even industrial devices, because our example is for the home, but it's applicable to industry in general. So we don't have problem with NAT. Actually, in our real scenario, we will show a demo right now connecting to my home. I don't have IPv6 connectivity. I have a 3COM router that has a NAT. So the way I use to connect to this box is using protocol 41 forwarding. That it's one of the protocols that in Eurosys we are working and have already submitted to IETF. We use only a single port. We use either port 80 without security or with SSL 433. And the reason for wanting to use a single port is because when I am traveling, I can always design an application to connect different devices or different services, and I can say, okay, I have a single IPv4 address in my home, let's put every device or every service in a different port. But when I am traveling, usually I find proxies, or I find some kind of firewall, and I can only use typically 2 ports, 80 and 433. So it means we need to make sure that the applications are able to work with a single port. So it's no meaning to configure our NAT box to forward different internal or private addresses to different ports. That will not work in most of the situations. We use Tomcat server that of course support IPv6. The application works in any operating system. We use also GSP, Java 1.5 that already supports IPv6, and also development kit that is offered by Siemens that also supports now IPv6. Let's skip this one. One of the technologies that we are using, and it's a very, very simple technology, is X10. X10 is a very well-known technology that allows using the electricity network, not using high bandwidth. It's only very low bit rate, 50 or 60 depending on the network frequency. But X10 allows just to go to the switch. I don't see the switch in this room. Yes, so over the door. Get the switch, take the switch out, put a switch that supports X10, and then you have an X10 interface, usually a serial port, a serial device connected to the serial port of the PC, and then you can address any device using the X10 and switch it on, off, or dim the light, or whatever. This is a very cheap technology. It's very easy to install. Of course, it don't provide a lot of functionalities, but in most of the cases, it's more than enough, because I just want to make sure that I can switch off my heater if my plane is delayed and I will be there one day after or whatever, to don't spend money heating the home while I am not there, for example. So we have built a bridge from X10 to universal plug and play. And then the control points, the universal plug and play control points, could execute actions over X10 devices. Okay. Let's go directly to the demo and finish there. Basically, just to say, X10 is a very simple way to do that, but of course, we are providing interfaces for other technologies. We have technologies like A-Bus or Longworks and much more. So we can use other technologies for doing that. And something that I also agree with the conclusion from Patrick, it's very important for the application developers to understand that even when we don't have today native IPv6 access networks, you still can develop applications, and this is a very good example, taking advantage of transition protocols. We can use IPv4 networks to transport, like we use today VPNs to transport our IPv6 information and make sure to exploit already IPv6 features while the deployment of IPv6 will take longer probably in access networks, at least in all access networks. Maybe new access networks will bring already dual stack or IPv6. But today most of us have normal, regular IPv4 only and will not be upgraded, at least not in the access part, very soon. So we just need to take advantage of that. So if you are an application developer, make sure that you are already building your application with support of IPv6. And in this way, you will keep the support of IPv4 for your existing applications. Nothing to change. So this is my actual home. I have an alarm system. I have cameras, a thermostat, microphones, speakers. I have different type of technologies. I use X10. I use PLC, wireless LAN. The cameras, for example, are already IPv6 enabled. And I have some blinds, I have lights, I can put some water to my dogs. And let's see the demo if it works. I am going to connect using HTTPS. I tried it before, it worked. I already opened it here to go faster. A view of the 4 cameras I have, so you can see here 3 windows with the blinds. 2 of them are already open. This one is the one that access to the garden. You can see here in the garden the pot with the water for the dogs. Okay. The network is working with IPv6. It worked before. Yeah, it seems no. Something is not working. Let's see HTTP. It seems yes. Okay, here is it. Yeah. I typed the wrong password. Let's go to HTTPS. No. I think I am typing one letter wrong in the password, but I cannot see it. Okay. But something is strange in the network because the cameras are not refreshing. Now again, I don't know. That's something wrong in the network. So for example, let's open blind 2, that is the one for the dogs. The interface is not the nicer one because I want to have a very, very good control of everything, but we have also a more user-oriented interface. And if everything comes well, I have a very small DSL, so of course the video takes time, so I hit F5 to refresh, but you will see probably if everything is working that the blind is opening, you can see already. And let's see, refresh again to go faster. And the dogs, of course, they expect I am there opening the door, so they will be waiting for me to open the window. But luck, I am not there, sorry. I can also open this one. Yeah, you see the dogs there? So, well... this is the interface that we have more user-oriented, but I wanted to show you that we have a lot of controls, we can do a lot of functionalities. If I actually go to my home with a new freezer or washing machine and already supports universal plug and play, for example, here you can see I have a wireless access point from Buffalo, and it's detected because already supports universal plug and play. So if I go with any new device supporting universal plug and play, I will get directly access to this device and I can control it. It's not coming. And that's it. Just to say that there is a lot of business possibilities. You see the one in the top, Buffalo. So if I click there, actually the plug and play control is disabled, but if I enable it, I will be able to control my wireless access point. So the question is, a lot of devices can come to the home. And I know a lot of Japanese companies like Sony, Matsushita, all them are already working on devices that can bring universal plug and play and other features, of course, with IPv6. And we will have a lot of possibilities, a lot of new business models, because all this I am doing myself. But most of the people will prefer to have a company taking care of the surveillance of the home or the alarm or something like that. So that's it. Thank you.
Okay, if there's any questions, we have to switch the cable back again, so very quick.
You have your slide from the...
Okay, so the next presentation is quite an interesting one. One of the big drivers of IP version 6 is from the Asia-Pacific region, and China has been very influential in this area as well. And so we're very pleased to have with us today Professor Xing Li, who is the Deputy Director of CERNET, the Chinese National Research Network. So with that, if I could hand over to Professor Li.
Thank you. Good morning. I'd like to give you a brief introduction for the IPv6 development in China. Okay, so that's the outline. The first thing is the telephone users in China, and there are about more than 200 million fixed line telephone users, and it's almost another 200 million mobile users. So China has the largest telephone user population in the world. And the second thing I like to mention is China currently is the second largest internet population in the world, just after United States. So that's the second figure. And the bar chart actually represents the distribution of the users. For example, the largest internet user population are students, which are our customers. and the others are professionals and whatever. Okay, so the China Internet estimation, because there are about 1.2 billion population in mainland China. If one person requires one IP address, there will be about 72 Class A equivalent required. And currently, China only has about less than 4 Class A equivalent. If you compare with the fact China is the second largest internet population in the world. And we all know for the existing IPv4, there are about 100/8, Class A equivalent left. Another fact is within 10 years, probably the population in India will exceed the population in China. So there is no enough IP addresses. The rest are just for your reference. If every Chinese use a very slow dial-up modem connected to internet 1 hour per day, then aggregated bandwidth will be 1,680 Gbps, which is a big challenge for the router vendors, for example, Cisco, Juniper, and others. Right. So it seems IPv6 is a quite natural choice for China. And China, actually, we started IPv6 trial back to 1998. For CERNET, we are the first network connected to 6-bone at that time. And also in 1999, Ministry of Science and Technology support a very small IPv6 demo project. And later, that's quite interesting, is we had a conference on networking, and I talked about CERNET, and Nokia talked about mobile phones. Then after the meeting, we got together because we believe every student needs an IP address, and the Nokia is thinking every mobile phone needs an IP address. So there were a joint project by CERNET and Nokia for IPv6 development. And in the year 2000, actually, we got funding from Natural Science Foundation of China, which a little bit similar to NSF in the United States, to run NSFCnet. And it is a small network in Beijing metropolitan area, but by that time the speed is quite high, it's 2.5G, and it is dual stack. In the year 2001, again, Ministry of Science and Technology fund research on the development of routers, especially for IPv6 routers. And I will show the results later in this presentation. And again, this year, IPv6 Metropolitan Demo System funded by China Academy of Sciences. And in the year 2002, Ministry of Information Industry, which is the former MPT, fund 60net project. And so it seems us, actually, our boss is MOE, Ministry of Education, Ministry of Science and Technology, China Academy of Sciences, and finally, Ministry of Information Industry are all interested on IPv6. And another thing is, in the year 2002, Japanese are very active and talk to Ministry of State Planning Commission, and there is a project called China-Japan IPv6.
USB network.
Okay, we can carry on. We can carry on. I've got the presentation
It's
here.
an XP. It's an XP. Type shoot down the slash question mark, and there is an option to kill the shoot down. You have 20 seconds. But you have only 30 seconds. Yeah.
What was it? Shut down what? Shut down what?
The slash question mark, because I don't remember the option. The option to kill it. Abort the shoot down. Minus A. Minus E. Shut down minus A. Minus A. Okay. Shut down minus A. Okay.
Oh, okay. Let me continue. Okay.
I have your presentation.
Okay, that's good.
I can,
That's fine. Yeah.
okay. Sorry about that.
Okay, that's fine. Okay, so for China-Japan IPv6 project, the Japanese really see the internet population in China and as a big market. And so actually CERNET, because we have a DWDM system, so we provide transport network. And the Japanese actually provide routers. And 3 vendors from Japan participate in this project, which is NEC, Hitachi, and Fujitsu. And the network itself actually it's quite big. It's connecting Beijing, Shanghai, and Guangzhou. The total distance is more than 3,000 kilometers. And this network is running. Another thing, actually, last year there is a quite big initiative, which actually there are 8 ministries in Chinese government get together, first time to start CNGI project, which is China Next Generation Internet Project. And we bid for the funding for that, and in this year we formally got the funding, and it is CERNET 2. And so some graphs, figures. This is the CERNET IPv6 testbed from the very beginning. And for CNGI structure, actually it's quite big. There consists of 4 parts: the engineering part, the test bed, test and demonstration, and the research development. And there are some basic research which will be funded by Natural Science Foundation of China. And the key technology development which will be funded by Ministry of Science and Technology, and the industry which we are focused on services, the tackle services, applications, and the hardware, software development. So the whole funding will support all of this. Another quite interesting thing is we are National Research Education Network. However, because there are many government entities involved, so there will be multiple backbones. And CERNET 2 is the only academic network. Others are all commercial service providers, and multiple backbone and 2 internet exchange points. So that's the members involved. For CERNET, for our bid, we got 12 cities to set up POPs. China Telecom, which is the largest internet service provider in China, 7. China Unicom, China NetCom plus China Academy of Sciences, 7 nodes. China Mobile, 7. China Railcar, 1. And so, add together, there are 38 POPs for CNGI backbone. Some are overlapped. So, for CERNET, as I mentioned earlier, and I also talked yesterday, CERNET is the largest academic internet backbone in China. Currently, we have a transport network using Lucent equipment, which the total bandwidth is 40 Gbps. And our layer 3 network, we are using Cisco routers currently, and 8 POPs connected via multiple 2.5G links, and the rest city actually connected via multiple OC3 links. We cover all the provincial capitals in mainland China, including, for example, Lhasa in Tibet. And we have about 1,500 universities connected to CERNET backbone, and the total user is about 15 million, quite big. And the links, actually we have link to United States. Currently it's a OC12 link, and we have link T3 to Star Tab, T3 to Tokyo Exchange Point of Asia Pacific Advanced Networking, and we have one link which is the only layer 3 link to Europe, which is the peering between CERNET and the GENET in United Kingdom. And for CERNET 2, actually this is the designed CERNET 2 topology. And for 5 cities, the link speed will be 10G. And the total cities, actually the government wants us to build 13 cities, but we actually, MOE want us to connect 20 cities, which will connect about 200 research universities in China. And another thing is, CERNET 2 is pure IPv6. I mean pure or native IPv6 means there is no dual stack. It is IPv6 only. I will back to that topic earlier. And the challenges, as I mentioned earlier, there are lots of challenges for the IPv6 development. Based on our understanding, scalability is one of them. And routing. Currently, the IPv6 space is very big, but the routing table is quite small. However, if a lot of multi-homing introduced, we don't know what will happen. And the second is functionality. And we are focusing on the highest performance applications. So China Grid, we are on top of CERNET 2. And mobility, multicast, and the security, there are several things. And the services, we believe, probably if some application besides the grid or high performance, we are not really need IPv6. However, for the smaller devices, IPv6 is the must. Also the charging model. I like to mention starting from January 1st, 1997, actually CERNET is self-funded, which is a combine of flat rate plus volume-based charging. And the CERNET 2, for IPv6, we are thinking maybe we can do something better. And transition is another thing. For the original IPv6 design, we like to set up terminals as much as possible. But currently, because we are running a native IPv6 network, my job is to try to kill terminals, because terminals make a big chaos on the routing. So the comparison of CERNET and the CERNET 2. CERNET, we are still providing IPv4 services to about 1,000, more than 1,000 member universities. However, within that, about 200 research universities. They were connected to CERNET 2 for next generation applications. For CERNET, we have 36 cities covered. For CERNET 2, only 20 cities because most of the research universities stay in those cities. And for CERNET, it's membership, and the CERNET 2 is consultant. And the routing for CERNET global, and the CERNET 2, which is global IPv6 plus some research networks. Topology, CERNET is 3-layer structure: regional network, provincial network, and the campus networks. But for CERNET 2, which is flat structure, and those are the routing protocols. For CERNET, the minimum speed connection speed is 2 meg. However, CERNET 2, 1G or above. And some interesting things we are doing. One is IPv6 BGP analysis, the dynamics of IPv6. And the second, we are running standard video on demand and the high definition television applications on CERNET 2. And this is the joint project by us and Korean KAIST, and also, which is quite impressive. Another thing is, if you take a look, this is the Cisco router, and this is the router made in China, high performance IPv6. The interface can support 2.5G BPS. And another thing, actually, I have a small team working on search engines. So our group is working on IPv6 search engine. Frankly speaking, there are not many materials. However, the side effect is we can see the development of IPv6 content in different regions. So, thank you very much.
Okay, thank you very much for that. I have to switch over the presentation, so if there are any questions whilst I'm doing that, then we'll be happy to take any. Okay, we do have just one more presentation in this session. I do apologise that we're running slightly late, but I do hope you'll bear with us, and we can get off to lunch very shortly. Which were your slides again?
That one.
This one?
Yeah, transition.
Okay, so the next presentation is on managed IPv6 transitioning architectures. It will be given by Michael McKay of Lancaster University.
What do I press?
Working?
Nothing doing, man.
Try again. Okay.
Right, well, good morning, afternoon.
Should have been morning.
I have like minus 10 minutes now, so I'm going to be very quick and I'm going to rush through these. What I'm going to present today is the work I've been doing for my PhD on managed transitioning architectures. When we started looking at this a couple of years ago, there wasn't a great deal of work out there, so we had to decide what sort of thing we wanted to do. And we really defined it as something that would support the actual deployment and operation of transitioning mechanisms within a network environment. Yeah. One of the things we decided fairly early on was that we'd have a lot more potential if you coupled this with a sort of management framework, so you would have a sort of two-tiered approach. And that's what I'm going to kind of structure my talk like today. So I'm going to go very briefly into the background on transitioning architectures, talk a little bit about management, and then kind of wrap it all up towards the end. So, yeah, I mean, recently there's been a little bit more interest in this sort of area, and there is now a draft available written by Pekka. And that really goes into the basic principles, the guidelines, if you like, of developing like a transitioning architecture. the principles are fairly straightforward. It has to be simple, has to be robust, secure, that sort of thing. And it just talks about the service sort of allocation issues, that sort of thing. What we wanted to do was take this a stage further. So if we're going to implement something, we have to look at the actual practical deployment issues. So things like the mechanism integration, how you put them in, take them out, that sort of process. And obviously the interaction, which has been a little bit of work has been done on that before. Things like, which mechanisms complement each other, which ones will work well in this sort of architecture, that sort of thing. As I say, we wanted to do a sort of two-tiered approach, and one of the things we looked at was transition management. This would be quite good. It would supplement the sort of administrative properties that you get of putting together some sort of architecture. And obviously this would be quite heavily a subset of IPv6 network management, which has been a major issue for a good few years now. What we decided to do was to put together a SNMP sort of framework. They were given sort of fault management, monitoring sorts of properties. So we moved on to the design issues that was related with that. Obviously, you would need IPv6 SNMP support, which is more or less available these days. But the real issue was the transitioning MIB. As we've heard earlier today, the transitioning issue, the MIB issues for IPv6 are fairly substantial. And what we thought we'd do is try to put together like a prototype, if you like, transitioning MIB that would hold this sort of information, and that's what we've done. We've got a prototype specification, a working prototype, together now. And the next step, which was going to happen last week, is probably going to be next week now, is we're going to take that into the 6net framework, so WP2, WP6, and we're going to try and get some sort of, stimulate some sort of discussion there and see if we can come up with something a little bit more substantial. So, in terms of the actual architecture, we called it STA because it sounds good, basically. What it is an administration and management framework that will be applicable for large-scale operators, people who have managed networks in the first place, basically. One of the things we tried to make sure was that the amount of modification that you would have to do to actually support these mechanisms was minimal, so it would mainly be administrative as opposed to operational. And as I said before, it would be a two-tiered design, so you have your dynamic transitioning frame and you have your SNMP management. What we wanted to do, essentially why we're doing it, is we wanted to put together a framework that would be applicable for the lifetime of, say, the transitioning process. So say if an operator decided to deploy IPv6 in some way, they would deploy this with a certain set, if you like, of transitioning mechanisms. And as their requirements changed over time, so they would put mechanisms in, take them out, scale them up, scale them down, performance-related changes, that sort of thing. And we wanted to put something together that would actually support that and make that easier to do. Obviously, another good advantage that you have with this is it has simplified operation management properties. So you have unified allocation of addresses. If everything in the transitioning plane, if you like, is brought together in a single place, then you can do better things with it. The other thing that we wanted to do, which to a degree I suppose ties into what Geordie was talking about earlier today, is we wanted to introduce, if you like, a service-based approach to transitioning. So you would have the operator would be able to optimize the sort of mechanisms that are available, who can access them, what sort of performance you receive, scalability, that sort of thing. So you can put together a much more dynamic sort of transitioning framework for use within large networks. Very quickly I go into the actual design. As you can see, we've got the transitioning and the management plane. The central component, as you can see, is what we call the STA server here, which does all the administration and management functionality. The other thing I would say is, as you can see down here, we've decided to divide the transitioning elements that we deploy into these three categories. So we have body devices, server devices, and hosts. Just to go into a little bit of detail what they are, the hosts obviously, anything that has some sort of complication, some sort of transitioning functionality within the host would go there, but obviously that's wants to be kept to a minimum. The second category are servers, so that's the sort of thing that doesn't actually handle network traffic, but does a sort of administration type thing, so tunnel brokers, DSTM servers, that sort of thing. And then obviously the final one is what you would probably think of if you thought of a transitioning mechanism, so like an endpoint translator relay, something that's sat on the border that's actually handling the traffic. And we thought it was a good idea to actually break it down into these three categories so you could do more interesting things with them as groups. This is actually the last slide, so I'll wrap this up. What we ultimately want to be able to do is make this applicable to pretty much any sort of transitioning scenario, if you like. So any sort of operator that wants to do any sort of transitioning would deploy this, and whether it's, say, an IPv6 only, so that'll be very interoperation oriented, or something that we class as a more more traditional sort of approach, so you have tunneling, you have interoperation, and that would obviously vary over time. So yeah, that's pretty much it. We wanted just to do something that was very widely applicable, that had, like I say, this management and this transitioning unified approach that could be used by a wide number of people and used for the duration of the process, basically. So I did have an example, but I'll skip through that. And that's the end. Thank you very much.
Thank you, Michael, for that very concise presentation, which means that we will we can go to lunch. If you have any questions for Michael, then please approach him during the lunchtime or later in the coffee break. So just to remind you that this workshop continues at 2 o'clock this afternoon after lunch, and of course there is the IPv6 cluster meeting at 4 o'clock. Okay, thank you.
Ένα, δύο. Μπορούμε να σβήσουμε τα ηχεία μα, είναι για να μην ακούγεται εδώ πέρα μέσα έτσι.
Εντάξει,
Αλαλαλαλα.
στην λίγο στις κανονικές συνθήκες. Α, να ζήσουμε τα ηχεία, λες. Μα αυτός από τα ηχεία παίρνει τον ήχο. Από τα ηχεία βγαίνει.
Από τα ηχεία παίρνει τον ήχο, δεν είναι καλωτιαμένος δηλαδή. Ωραίος. Πίστευτα, αυτές ταχύτητες είναι αυτές.
1 κιλομπάιτ, έτσι. Εντάξει, καλή να δεν είναι τρομερή.
20 κιλομπάιτ. Σε αυτό το σύστημα όμως, οι άλλοι, το δίκτυο.
Το δίκτυο είναι πιο άλλο. Α, ποια είναι. Καλή, καλή.
Ναι.
Δεν μιλάει.
Μιλάμε, μιλάμε.
Μιλάμε έτσι, μιλάμε σε εμάς.
Τι να κάνουμε. Κάναμε ένα-δύο συνέχεια έτσι.
Αυτό είναι σιγανό, εσύ, εντάξει. Μην αναφέρεις τίποτα για εδώ πέρα, έτσι, γιατί θα καταλαβαίνεις.
Ναι. Ναι. Κάτσε.
Ένα, δύο, τρία.
Στο PC απαντώ.
Το κάνει mute στο PC μας.
Στο πολύ που ζωή μου βάλει τίποτα από εδώ. Όχι.
Το πολύ που ζωή.
Ναι. Το πολύ που ζωή μας από κάτω δεν έχει λάπτοπ. Έχει λάπτοπ εδώ πέρα από κάτω κανένα από κάτω.
Όχι. Εσύ λάπτοπ έχουμε πολλά αρέσει. Λάπτοπ έχουν πολλά συνδεμένα. Πολλά έχουν εδώ μέσα. Δεν είναι μόνο αυτό. Ένα, δύο, τρία, τέσσερα.
Ένα, δύο, τρία, τέσσερα. Ένα, δύο.
Εσύ λάπτοπ έχουν πολλά μυστήρια. Αυτές δεν είχαν όμως αυτό. Έχουν βάλει πολλά πολυμπιζάκια.
Τέτοιο λάπτοπ θέλουμε, το καλύτερο. Ωραίο λάπτοπ.
Είσαι έτοιμος να δεις κάτι. Να μην μιλήσεις, αυτό το απλά δες το.
Είναι τραγικός όμως.
Αυτό είναι αυτό. Αυτό το... Φύγαμε.
Ναι, ένα, δύο, τρία. Μίλα κι εσύ, γίνομαι μόνος μου.
Λοιπόν, εντάξει, θα πούμε ότι